As I've mentioned before, x causes y. Function notation is just another way to write an equation that emphasizes this fact, that x causes y. In function notation, x is our input, and instead of y, we have the f of x, or the function with x put into it, that is our output. So really this is pretty simple. It's just getting used to seeing it written another way. So as they've shown here, if we input a 0 for x, 0 plus 2 is 2, and therefore our f of x, our function, our y, our output, is 2. And we get an ordered pair, x, y, or x and the f of x. So let's go ahead and fill in the rest of these, if we can. So if we plug in a 1 for x, 1 plus 2 is 3, so the f of x is 3. And our ordered pair now is 1, 3. If we plug in 2 for x, the f of x, the f of 2, let's just go ahead and use that notation. The f of 2 would be 2 plus 2, which is 4. And so the f of x, or the f of 2, is 4. And we now have 2, 4. The next one, we'll plug in 3. So the f of 3, 3 plus 2 is 5. So the f of x, or the f of 3, is 5. And our ordered pair is 3, 5. One more to go. The f of 4, x plus 2, 4 plus 2 is 6. And the f of 4, or f of x, of 4 is going to be 6. So our ordered pair is 4, 6. Now, let's take a look at some terminology and then at problem number 5. First of all, you'll see this terminology, domain and range. Domain is the input. It's x. Range is the output. It's like what y was, except we're going to use the f of x. Or it could be the f of another variable. But it's your output. It's your dependent variable. So how can we remember this? Well, the domain is our limitation. It's what we start with. And range is the range of answers that we get. So they want us to describe what the graph of this function looks like if the domain, meaning our input, is 0, 1, 2, 3, 4. Well, the graph of the function would be the graph of these points right here. So, and what is this going to look like? Well, we've got 0, 2, and these are all positive, so I'm going to do a graph that is only positive. So we've got 0. Well, here, let's put in some lines. We've got 0, 2. That would be right here. Then we have 1, 3. 0, 2, and then 1, 3, and 2, 4, and 5, and 3, 5. What are we getting? If we keep going here, we're going to get dots that lie in a straight line. So, how would we describe this? How about these dots lie in a straight line? Actually, I'm going to change my wording just slightly. Rather than calling them dots, let's call them points. So these points lie in a straight line.